Chemists, this is Allie,
Kenzie,
and Tanner.
Today we will be discussing the solubility of KMnO4, also known as potassium permanganate, in water, hexane, and ethanol. When tested, the KMnO4 only dissolved completely in water, turning it into a deep purple solution. In hexane and ethanol, the KMnO4 remained in its crystal state. Water is a strongly polar covalent molecule. This allows the water molecules to be bonded together by hydrogen bonds, which are a type of dipole-dipole attraction force between a hydrogen atom and a very electronegative atom. In this case, the hydrogen bonds are between the strong positive hydrogen atoms of one molecule of water and the strong negative oxygen atom of another molecule. These bonds give water the ability to pull apart the KMnO4 and dissolve it. The hydrogen atoms in water are partially positively charged, and the oxygen atoms are partially negatively charged because oxygen has a much higher electronegativity than hydrogen. KMnO4 is an ionic compound, meaning it is consisting of positive and negative ions attracting, those being K plus and MnO4 minus. With that being said, the idea of opposites attract applies, and the water molecules rotate so that the slightly negative oxygen attracts to and surrounds the potassium ions. Likewise, the slightly positive hydrogen end of the water molecule attracts to and surrounds the permanganate. These attractions dissociate the K plus and MnO4 minus ions, causing the solid KMnO4 to dissolve. Now on to KMnO4 and hexane. Hexane, however, a nonpolar solvent, does not dissolve the ionic compound potassium permanganate. Hexane is a type of hydrocarbon with the molecular formula of C6H14. The hexane has no significant partial charges between any of the atoms, meaning that the difference in electronegativity is not great enough to make a polar molecule. Because of this, the polar molecule KMnO4 cannot be dissolved by the nonpolar solvent. When potassium permanganate is added to a solution of hexane, the ionic potassium permanganate compound will disperse throughout the hexane without dissolving due to the fact that the ionic bonds holding potassium permanganate together result in a very polar molecule. The polar molecules are more strongly attracted to each other than they are to the nonpolar solvent. The ionic attractions are too strong to be broken apart by the nonpolar solvent, meaning that the nonpolar solvent will surround the polar ionic compound without reacting with it. Finally, let's take a more in-depth look at what happens when KMnO4 is added to ethanol. Potassium permanganate is insoluble in ethanol. Though ethanol is a polar compound and would be expected to dissolve potassium permanganate, which is an ionic compound, it does not release enough energy to dissolve the strong attractions between the potassium and the permanganate ions. However, part of the ethanol molecule, the carbon chain, is nonpolar, which contributes to the fact that this molecule is not strong enough to break apart the attraction between the atoms and potassium permanganate. The potassium permanganate is held together by ionic bonds, while ethanol is held together by hydrogen bonds. And since the energy released is not strong enough to break apart these bonds, the potassium permanganate is not able to bond with the ethanol. Therefore, ethanol is not strong enough to dissolve potassium permanganate. Thanks for watching!